Hey everyone! So today we are going to be graphing logarithmic functions. So yesterday we did exponentials. Today we're going to do logarithmic. And you're going to notice that the process is very, very similar, but we'll have some key differences here. Okay? So first thing, as always, here's kind of our generic little formula here. So we have a times log base b of x minus h plus k. As always, that number within the parentheses, within our argument there that's attached to our x, is our horizontal shift, left or right, opposite of what we think. As always, our k value is our vertical shift, up or down. Our a value is our multiplier. Again, that's telling us how fast we're growing or how fast we're shrinking. And then our b, just like yesterday, b is our base. All right, so you can see this is the first one we are going to graph. So just like yesterday, I'm going to figure out where my x goes. So remember, number inside tells us our horizontal shift, opposite of what we think. So this is telling us we need to go right 1. And then our vertical shift, our k value, this is telling us we need to go up 3. So from my origin, I'm going to go right 1, up 3, and x marks the spot. So now let's take a look at what we haven't done anything with. So we haven't touched the log with the base of 4 or the x yet. Now, yesterday, this is where we made our xy table. So we're going to make our xy table here. And yesterday, we plugged in our basic 5 in for our x's. But I can't plug -2 in for x here because we can't have negative arguments. So what we are going to actually do is we are going to get this into exponential form. And remember, to get this into exponential form, I'm going to do a log roll. And you can notice my y equals is over here, so it's going to kind of be a backwards log roll. Okay, so let's go ahead and get this in exponential form using our log roll. So start with my base, what it equals, what's left. So in exponential form, this would actually be 4 to the power of y equals x. So now notice our y is actually in the exponent in exponential form. So now what we're going to do is, because y is in the exponent, we're going to put the basic 5 in for y. So if we look back at yesterday's, we put the basic 5 in for x because x was the exponent. Today, because y is our exponent, we will put the basic 5 in for y. Okay, so you put the basic 5 in for whatever variable is in your exponent. All right, now let's go ahead and do that. So I'm going to plug in -2 for y. Again, remember, negative exponents flip. So this is going to become a fraction, and it's going to become 1/16. Same thing, let's go ahead and plug -1 in for y. It's going to flip and be 1/4. Plug in 0. We know anything to the power of 0 is just 1. 4 to the power of 1 is 4. And 4 squared is going to give me 16. All right. So now, again, still graph it the same way. So x still tells us left or right from our origin. And then y still tells us up or down. So this is telling me from my new origin, from my x value, I need to go right 1/16. So right 1/16 and down 2. Obviously, it's not going to be perfect because I don't know what 1/16 is, and I'm not going to split that little itty bitty square into 16 pieces. Just do the best you can, okay? All right. Same thing for this one. So this one's telling me I need to go right 1/4. We're going right because it's positive, and down 1 because it's negative. So from my new origin, from my x, I need to go right 1/4, down 1. This one, I'm going to go right 1, but I'm not going down or up at all. All right. This one's saying I need to go right 4, 1, 2, 3, 4, and up 1. And lastly, I need to go right 16, which is going to be way off my graph, and up 2, someplace over there. And now again, hopefully you're seeing that these values, it's going to go on forever, obviously. These values are going to get closer and closer and closer and closer to that line, and it's never going to cross it. So our asymptote today is actually a vertical asymptote. So notice how things are kind of flip-flopped today. It's a vertical asymptote. So our graph looks like this. All right, and since we have a vertical asymptote, that means our domain and range is going to be flip-flopped as well. So kind of like how we flip-flopped where we put in our basic 5, domain and range is going to be flip-flopped too. So our x values, notice there are no x values over here, none whatsoever. The smallest x value that we have is at 1. We want the values that are greater than that are bigger than 1. But again, just like yesterday, it's never going to be or equal to 1 because it can never cross that asymptote. All right, our y values then. Again, our y values are going on forever, so it's going to go forever down. And as it's growing out here, it will get bigger and bigger and bigger as well. So our y values, they all will be hit. So our y values for logarithmic equations is all reals. All right, well, let's go ahead and do another one. This time we have log base 2 of x plus 5 minus 2. So again, that number inside attached with the x tells us our horizontal shift to left or right, opposite of what we think. So this is saying we need to go left 5, and then our vertical shift is saying down 2. So I'm going to go ahead from my origin, go left 5 and down 2, make my x. All right, now let's take a look at what we haven't done anything with. So I haven't touched my log base 2 of x. And now again, we can't plug in negative values for x. So what we're going to do is we're going to do our log rule, a backwards log rule, to get this into exponential form. So we have 2 to the power of y equals x. And now I can do my table. Again, my y is in my exponent. So since my y is my exponent, that means I'm going to plug basic 5 in for my y. And let's go ahead and do that. So I'm going to plug negative 2 in for y. 2 to the power of negative 2 is 1/4. Keep on going. I'm going to get 1/2, 1, 2, and 4. All right, so again, x values tell us how far left or right we're moving, and y is how far up or down. So this is saying from my new origin, I need to go right 1/4, down 2. So from my origin, right 1/4, down 2. This one, I need to go right 1/2, down 1. This one, I'm going to right 1, but I'm not going up or down at all. Need to go right 2, up 1, because this is positive. So from my origin, right 2, up 1. And lastly, I need to go right 4, up 2. Let's just set that point right there. And again, I could put any value in for y, so this graph is going to go on forever. And we know it's going to get closer and closer and closer to this imaginary vertical line here. That is our asymptote. So if I look at our x values, there's no x values over here whatsoever. They stop at -5. So we want the x values that are greater than -5. But again, it can't be an or equal to because it will never be at -5. And then our range, we have every single y value imaginable. So our range is all reals. All right, so there's how we graph logarithmic equations or logarithmic functions.